When a charged particle moves in a magnetic field, the particle will feel a force as long as it is not moving parallel or antiparallel to the magnetic field. Note the absence of a force when the particle is stationary, and when the particle moves parallel to a magnetic field line. There will be a force when the particle moves at an angle to any magnetic field present. This force acts in a direction that is perpendicular to both the direction of the magnetic field and the direction of the charged particle's velocity. This creates a problem because we must consider all three spatial dimensions when dealing with this force, even though our figures are on a two-dimensional piece of paper. In this animation, we will find the direction of the magnetic force on a positive charge that is moving at some arbitrary angle relative to the magnetic field. To find this direction, we will use right-hand rule number 1. This animation will also show you how we cope with 3 dimensions on a two-dimensional figure. We start with a plane containing the x and y axes of a Cartesian coordinate system. This plane will also contain the velocity v of the charged particle and the magnetic field B. To apply right-hand rule number 1, make sure to use your right hand. This may sound silly, but using your left hand by mistake will give you the wrong answer. You will also get the wrong answer if you try to apply RHR number 1 to a moving negative charge, because the direction of the force on it by the magnetic field is directly opposite. The first step in using right-hand rule number 1 is to open up your hand so it is flat. Then, align the thumb of the right hand with the direction of the charged particle's velocity. As you can see from the drawing, this condition is met. However, the other 4 fingers must point in the direction of the magnetic field. This is not the case with our hand, so we have some work to do. To meet this condition, the hand must rotate about the thumb until the 4 fingers point in the direction of the magnetic field. Now that the thumb is aligned with the velocity and the 4 fingers point in the direction of the magnetic field, the palm of the hand will point in the direction of the magnetic force experienced by the positively charged particle. Notice that this force is perpendicular to both the particle's velocity and the direction of the magnetic field. There may be different ways to describe the direction of this force, and in this case you could say that the force points in the positive z direction because there is a clearly defined coordinate system. A different way to describe the direction of the force would be to say that it is upward, out of the plane containing the velocity and magnetic field vectors. How the direction of the magnetic force is best described will depend on the context of the problem you are working on.